Hi, Assalamualaikum. My name is Harith Naufal, along with my group colleagues, which is Faris Wawas and Ahmad Zarif. And for our MAT 183 subject, we are assigned to make a presentations on solving and answering questions following the topic of differentiations in calculus. And to start with our first questions, what is the meaning of differentiations? Now, in calculus, differentiation is the process of finding the derivative of a function with respect to a variable. Now, I've listed some three different meaning of differentiation based on the topic. First of all, we have geometric interpretations, where differentiation means tangent line of a curve at a point. Next one, you have definition in limit form, where differentiation is the derivative of a functions. And then we have physical interpretations, which differentiation means an instantaneous change or an instantaneous rate of change of a functions. The techniques of differentiations. First of all, we have the power rule. The power rule applies for any terms of the form x to the power of n, including fractions and negative powers. And then we have constant multiple rule. Constant multiple rule are used when a function is multiplied by a constant. And then the third one is sum and difference rule. And this rule are used when functions are added or subtracted to another functions. And then we have product rule. Product rule are used when two functions are multiplied together. The fifth one is quotient rule. Quotient rule are used when a function is divided by another functions. And then another one we have chain rule. Chain rule is for a composite function, which means a functions inside another functions. And then we have the implicit differentiations. Implicit differentiation is when y is given implicitly, basically an equation connecting x and y. And then we have logarithmic differentiations. Logarithmic differentiation useful when functions involve variables in exponents or complex products. And then the last one, you have high order derivative. High order derivative are used to find acceleration, concavity, and curvature. And then to solve for questions 2a, given 2x squared cos x plus 2, we will be needed to find the derivative of these expressions. To do that, I'm going to use the product rule. Why? Because this expression is a product of 2x squared multiplied by cos x plus 2. So we're going to separate it into two products, which is u is going to be 2x squared, and then v is going to be cos x plus 2. So we're going to use the product rule, which is u prime times v plus u times v prime. And if you're wondering what is this prime is, the prime is basically means the derivative of the functions. And then for the first step, we're gonna differentiate ux equals to 2x squared, and this expression we're going to use the power rule. So the 2 over here, the 2 power is going to be derived into here and going to multiply it to the 2x variables. So it's going to be 4x, and then the 2 is going to be subtracted by 1, which is basically just 1, and then we don't write it in the expressions over here. And then for step 2, we're going to differentiate Vx. And then for that, we're going to use the chain rule, because there's a functions inside another functions. So what we're going to be doing is differentiate cos x plus 2, going to be negative since x plus 2. And then we're going to multiply it by x plus 2. And then x plus 2 is equals to 1. So our v prime is going to be negative sin x plus 2. And then we apply it into the product rule. Basically just plug it in. We're going to plug in u prime over here, and then v over here, and then u over here, and then v prime over here. So we're going to end up with 4x cos x plus 2, and then 2x squared negative sin x plus 2. And then for questions 2b, given y equals to 3x plus 1, over sin x. So what we're going to do is compute the derivatives that we did earlier. So u3x plus 1 is going to be u prime equals to 3. And then v equals to sin x going to be v prime equals to cos x. So we plug it into the quotient rule, which is, if I remember, it is dy dx equals to v times u prime plus it's going to be minus u times b prime equals to v to the power of 2. So we're going to plug everything into here, and we're going to end up with this expressions over here. And then basically there's not much simplifying needed, so our final answer will be this.
My name is Muhammad Faris Fawas. I'm going to answer this question. Given y log 2x minus exponent power of 3x plus 2 minus tangent 3y equals to 0. Find dy over dx using implicit differentiation. Okay, first, y log 2x. This is product of y multiplied by log 2x. This is y. We are going to use product rule. Okay. First, we have to differentiate the u and v product. So our u is equal to y and our v equal to log 2x. So our derivatives of u prime is going to be dy over dx, and our derivative of v prime is 1 over x. So we all end up with dy over dx log 2x plus y 1 over x. Okay. So for this part, we have minus exponent to the power of 3x plus 2. So the way we are going to differentiate this is deriving the 3 from the power. And then we can multiply the 3 and end up with minus 3 exponent power of 3x plus 2. Okay, first of all, we're going to differentiate the negative tangent 3y into negative second square 3y. And we are going to derive the 3y and differentiate it into 3 dy over dx. After that, we simplify it into 3 second square 3y multiply dy over dx. So after all of that, we are going to combine all of the derivative of the three product we did. And so we are going to get these expressions. After that, we are going to need to have the dy over dx expression at the left hand side. So from this, we are going to factorize dy over dx, and we are going to get this answer.
And today I will guide you guys how to solve the question number 4. Use linear approximation to estimate the value of 4 root 15.99 minus 2 over square root 15.99. Correct to 3 decimal places. So how to easily get the answer? First of all, we have to list out all the information that we have. First one, x value. We got x value, which is the number is 15.99, and the x naught is the nearest one to 15.99, which is 16. And for data x, how to get data x? We have to x minus x naught, which is negative 0.01. And we have to make this number to function, which is 4 root x minus 2 over square root x. And for f prime, we have to derivative the function, which is 1 over 4 x power negative 3 over 4 minus x power negative 3 over 2. After that, we have to use linear approximation equation, which is this one. So so we can see here, which is fx. This x, we have to apply the number into the fx, and x naught is 16, and the data x is negative 0.01. So we have to apply the value inside the equation. So we got 16 power 1 over 4 minus 2 times 16 power negative 1 over 2 plus 1 over 4 times 16 power negative 3 over 4 minus 16 power negative 3 over 2 times negative 0.01. And for this bracket we got 1.5, and for this bracket we got 0.1415625 times 10 power negative 3. So we have to minus these two number, and we got 1.4998437.5. So we can round to three decimal places, which is we got the answer 1.5. So that's the final answer. Thank you.